Asking the right questions can foster student curiosity and have a direct impact on student engagement and interest and assist students in driving self learning. Questioning is the key by which teachers find out what pupils already know, what they understand, and where they need further clarity. This process is crucial in ensuring that a teacher's effort has the intended learning output. So, how do you think questions can bring an informed change? Well, a question, if designed well, can help measure the conceptual understanding of the students beyond textbook questions. Good questions will tell us what students have understood rather than what they can remember. Quality questions can give insightful data into misconceptions and the learning gaps that students might have. And in return, it ensures that any such gaps are corrected immediately. They help give feedback to the teachers at the beginning, during, or at the end of the topic being taught, whether or not the teaching strategy has worked, and if not, what can be done to make it better. Good questions thus aid in informed classroom instruction. They also give feedback to the students regarding their level of understanding. It must be noted here that a test is not a remedy. Rather, quality assessments give us data and insights on the basis of which we can plan the remedies. We know that questions influence the learning process. Hence, a properly framed question stimulates critical thinking, which means the student has to apply the concept learned to arrive at the answer. How does that really happen though? Take a look at these two questions. Do you think there is a difference between the two questions? Yes. What is the difference? Let us check that out. The first question is simply asking the student to name a particular phase of the moon. It does not matter if the student does not know how and why these phases occur and answers only on the basis of his memory. The word indicating the correct answer, full moon. The second question, on the other hand, would make the child think as to why the phases of the moon occur in the first place. It tests and gives us insights about the child's understanding of the concept rather than the learning of the concept. While the first question can be simply answered based on memory, the second question makes the student think. Hence, a good question stimulates critical thinking. What type of question will you ask? Do they change with the purpose of questioning? Is it that the first question is not helping the teachers at all? No, that is not the case. The first type of questions, which check memory, are more for classroom discussions or revision tests. These allow the teacher to ensure the knowledge of the term, quick revisions, and repeated exposure to the words that are important for the child to know. However, what the child needs to retain as understanding is how the phases occur. Hence, a summative or a diagnostic assessment should have more questions checking the whys of the concepts. A properly framed question distinguishes mechanical learning from learning with understanding. Such questions probe the students to apply their understanding in practical, real-life settings with the aim of testing their critical thinking and problem-solving skills. Let's try to understand through some examples how this happens. Look at the two questions given here, both testing degree measure of angles. What is the difference between the two? The first question has the angles in the standard orientation that are found in the textbooks, and the correct answer may be chosen by the student by simply memorizing it without the application of the concept of degree measure of an angle. Now, what do you think of the second question here? This question encourages the students to look at the angles in a different orientation and hence conclude that the bigger the opening of the two arms of an angle means the bigger the angle. It encourages the students to apply the concept of angles, hence gauging the depth of comprehension of the concept. Hence, it stimulates the child to think critically. Do we now understand how a good question can distinguish mechanical learning from learning with understanding? A good question focuses on the broader concept and not just on a specific information, and thereby encourages the student to apply the concepts learned to arrive at the answer. Let us now take a look at a math question based on circles. Now, typically, a grade 7 student who has a fair understanding of circles would be able to solve this question. However, it cannot be answered by a simple memorization of the concept of circles, but instead compels the child to apply the properties of the circle to arrive at the answer. Here, the child has to understand that since all the three girls are at points on the circle and the teacher is at the center, the girls would be equidistant from the teacher. Simply learning the definition of a radius and how to measure it will not help the child in answering the question. But rather, the child has to understand the property of the circle which states that every point on the boundary of the circle is at the same distance from the center, and hence come to the conclusion that all the three are at the same distance from the teacher. A question like this also makes the child go beyond textbook language and understand how the concepts they are learning in the textbook apply in the real world. Good questions also help us understand common errors that students might make or wrong notions that they might have. Here is a question asked in class 8. As you can see, most of the students have chosen option D, which is the incorrect answer. Students know that steam is the gaseous state of water. They also know the chemical formula of water. But this question now compels the students to combine both the known facts to answer the question. That is, as pure steam is also water, simply in a different state, its chemical composition is unchanged, and the answer will also be H2O. This question hence helps us understand a common wrong notion that the students might have. That is, pure steam does not have a chemical formula. After this assessment, we can take this data back to the classroom and address and remedy the said misconception. Questions also provide feedback on what students are learning. The number of students choosing a particular option for a question reflects the learning that has happened in the classroom. Here is a question that educational initiatives tested across grades 4, 6, and 8. The question here is testing the place value concept, where the question stem is not in the standard form as seen in textbooks. This is a very simple question, but it still challenges the rote practices or procedural learning. Looking at the performance percentage, it can be inferred that the concept of place value is not clear among the students from grades 4 to 8. The correct answer to the question given above is C, while most of the students have selected option A. They may have chosen A considering 7 in the hundreds place while 13 following it. They seem to be unclear with the concept of 13 tens being 130 and not 13. Similarly, students who have opted for B may have understood 13 tens to be 130, but instead of adding it to 700, they may place it after 7 as such. What are you able to infer from the data given here? The numbers also reflect that the misconception persists with the progression of the grades. Also, the major misconception changes with the grades, as option A seems to be the major misconception in grade 4, while it is reduced till grade 8. But only 48% have given the correct answer. That means that half of the grade 8 students do not have the correct understanding of place value concepts. This one is a classic example of how questions can provide feedback on what the students are actually learning. Let us have a look at another question. The question here is testing whether students are able to read and comprehend the information given in the passage and hence arrive at the correct answer. Here, option B is the correct answer. That is, the train is described as clinging to the mountainsides. However, based on the performance of the students, we observe that 62% of the students have selected option A, that is, the mountain curves. This shows us that a majority of the students are facing a challenge in reading comprehension and incorrectly inferring what the passage is trying to describe. Based on this information now, the teacher can take appropriate measures, say frequent practicing of reading comprehension and inference in the classroom to remediate this. Let us summarize what we have understood through these question examples. Good questions influence how and what students study. By understanding how a student thinks, where they struggle, and where they excel, teachers can direct their time and efforts productively to maximize the learning outcomes. It helps prepare the teaching methodology. Are we focusing on the definitions of technical terms and their memorization, or are we focusing on the conceptual understanding of what is being taught? Good questions can provide feedback to the teachers on what the students are learning so that the teachers can undertake informed classroom teaching. They will know exactly what the learning level is of every student. Such understanding promotes personalization of teaching and assists students in understanding in an attentive manner. Good questions can stimulate thinking and develop higher level thinking skills, strategies, and habits. What is the cognitive process that the child follows when answering a question in an assessment? Are they trying to remember what they have learned, or are they trying to apply what they have learned? Questions can also help us distinguish mechanical learning from learning with understanding. Mechanical learning is apparent learning, while learning with understanding is the real learning that stays with us and helps us identify the practical applications of what we are learning in our textbooks. And finally, questions also help us identify common misconceptions and errors so that steps can be taken for remediation. Once misconceptions are formed, they can influence future learning. It is imperative that these misconceptions are identified and remediated at the beginning of the learning process itself so that they do not impact future learning.